Hi, my name is Stuart Ozer, and my project is on using cellular automata to simulate wildfires. First, what is a cellular automata? A cellular automata is a digital representation or simulation of life. It has two states, alive and dead, and I added a third. I added burning. This allowed me to simulate forest fires. This project could actually be used to help firefighters actually see how a forest fire is going to spread and set up perimeters to stop the spread of these fires, saving a lot of natural resources that we would otherwise lose. Fires can spread to grasslands and forests alike, so we lose farmland and natural resources all at the same time. The first step I needed to do was generate code. So I made a program in IntelliJ IDEA that was able to take a map, generate a 2D array, or basically a grid of that map in pixels, as you can see in method, and return the result with a forest fire actually burning in real time and show me the result of that forest fire. Not only the image representation, but also the area burned in terms of number of cells. I compared this data that I gathered in the max number of cells burned for each of 5 trials for each of 18 different maps run. I compared that data to the real forest fires that ran of the maps that I took on November 10th. There was a real forest fire of each map on November 10th. You can see that in the data table, in the data and discussion of data. I compared these two and generated the graph. However, at this point, I realized I had made a crucial mistake. The current area burned for the real forest fires does not account for the time each fire had been burning. However, those simulated forest fires actually simulated them for the same amount of time for every fire. There are two possible solutions to this. Introduce a time variable in the program, or account for the time variable in collecting the current data. By analyzing these results, you realize that while the project and the model did not successfully predict the spread of these forest fires, as it had no predictive ability, there was no correlation between my simulated data and the real data. It did, however, actually show that the model was, in a way, successful. It generated a forest fire, and it showed the spread of that forest fire. The only error was in data collection. So, this is an accurate model, almost, with a few adjustments, of forest fires that can be used one day to save the world. Thank you.